Okay, so now we're going to talk about how bones are related to calcium in your body. And so it turns out that the amount of calcium in the blood has to be kept in a really strict balance within a specific range. We just did this whole section on neurons, and as you remember, for synapses to function properly, they have to have calcium in proper amounts. We're going to learn the same is true for the heart. There's just so many different physiological functions throughout the body that use calcium, and the blood delivers calcium to every place in the body, that it's really important that the blood always has the perfect amount of calcium. And we don't want it too high, we don't want it too low. So what I'd like to do is first just show you this here as we're thinking about calcium. That's not what I wanted to do. Okay, so again, like we said, calcium in the blood is going to be kept in this very specific range, not too high, not too low. But how do we get calcium into our bodies in the first place? Well, we eat it or drink it. Eat our cheese, eat our yogurt, drink our milk, that sort of stuff. It goes through our digestive system, and then it's going to be absorbed in our intestines, and the intestines send it directly to the blood. Okay, so food through the intestines into our blood. Now, once it's there in the blood, we can send some of it to the bones to store it, or we can also pull calcium out of the bones and send it back into the blood. So it turns out that this here is a two-way exchange. Some of this calcium in the blood we can send to the bones for storage, and we can pull stuff out of storage and put it back in the blood. Now, if we permanently want to rid the body of calcium, we are going to send it out to the kidneys, and it will be filtered out, and it will be lost in the urine. So we'll send calcium from the blood into the urine. That's how we can permanently get rid of calcium from our bodies. Okay. So the first scenario I want to talk about, and this is the scenario that tends to be more common, is what happens if we have low levels of calcium in our blood. Now, plasma is just the fluid non-cellular part of blood. Okay, so what happens when there are low calcium levels in our blood? Well, first, that's going to be sensed. And it turns out the thing that senses it is called the parathyroid gland. And what it's going to do is secrete a hormone. The hormone is called parathyroid hormone, abbreviated PTH. Parathyroid hormone is going to do a couple of things. First, it's going to go to the kidneys, and it is going to tell the kidneys, stop urinating out calcium. And it says any last bit of calcium that happens to get into the urine, you want to suck it back out of the urine and send it to the blood. We want to keep the calcium. Something else that the kidneys are going to do is they are going to release a hormone called calcitriol. That will go and travel to the intestines. And calcitriol tells the intestines, every last bit of calcium in that yogurt, in that cheese, in that milk, I want you to suck it all up and bring it inside the body. So it makes these intestines super efficient at absorbing calcium. Another thing that parathyroid hormone does is it comes over here to the bone, and it turns these osteoclasts, remember those are the ones that tear up bone, it puts them into overdrive. And it says, osteoclasts, I want you to start tearing up as much bone as you can. And when the osteoclasts tear up the bone matrix, they are going to send that calcium out into the blood. Okay, so just to recap, low calcium levels, we start low, okay? Parathyroid gland senses that, releases a hormone. Hormone tells kidneys, keep all the calcium inside the body, don't urinate it out. Kidneys tell intestines, hey intestines, bring more calcium in. And bone and parathyroid hormone tells the bone, hey, start releasing your calcium stores into the blood. So calcium is released into the blood from the bone. Calcium absorbed more quickly from the intestines. And less calcium is lost in the urine. So we started out with low calcium levels, okay, low levels. And in the end, we have now, through these 3 responses, raised levels of calcium. And now we're back in homeostasis. Now, remember, if you start with a decrease, and now you've increased it, negative feedback. Chapter 1. Okay, let's now talk about the opposite scenario. Instead of low blood calcium, we've got high blood calcium. So this time a different gland senses it, the thyroid gland. And it is going to secrete a hormone, but this time the hormone's name is calcitonin. It's got a different chemical structure. But calcitonin is going to travel to the same places. So first calcitonin goes to the kidneys, and it says, you know what, kidneys? We've got way too much calcium in the blood. I want you to start sending it out to the urine. Don't keep it. Get rid of it. The kidneys, they release less calcitriol, and so the digestive system, those intestines, they stop being efficient. If there's calcium in the yogurt, that calcium just passes right on through. It doesn't get absorbed into the body. Calcium in the milk passes right on through. Doesn't get absorbed into the body. And then calcitonin comes over here to bone, and instead of stimulating the osteoclasts, it inhibits them. It says, stop tearing calcium out of the bone. Leave it in there. And because the osteoblasts are still working at their normal rate, then overall bone is made stronger because you're putting more calcium into it. So again, as a recap, high blood calcium levels, thyroid gland senses that, releases the hormone calcitonin. Calcitonin tells kidneys, get rid of the calcium in the urine. Kidneys are not sending as much of this hormone calcitriol to the intestines, and so the intestines, they stop absorbing calcium from food and drink. And then calcitonin also goes over here to the bones, and it inhibits the osteoclasts and tells them, stop tearing up the bone matrix, leave the calcium there, and so overall calcium is stored in the bones. And so we started off with high calcium levels. We have now decreased those levels. Again, negative feedback. Okay. So this is how it's regulated. And so high calcium levels, because you're taking that calcium and putting it into the bones, it's going to make for denser bones and stronger bones. The opposite, low calcium levels, because we're tearing calcium out of the blood, out of the bone to send it to the blood, we don't have as much calcium in our bones, so our bones are going to be not as dense, and they're going to be weaker. So just to really hit home on this, let's go here. You can remind yourself what homeostasis is from Chapter 1 if you need to, and restate this phrase. I want you to know that calcium enters the body. It's in our food and drink, and enters through the digestive system. Okay, enters through the digestive system, delivered to the blood. So the two important locations for blood homeostasis, where calcium is found inside the body, well, the blood is one, has to be, and bone, that's where a huge percentage of calcium is stored. How does calcium leave the body? How do we permanently get rid of it? The urinary system, so through our urine. And just a reminder, blood calcium levels are maintained by negative feedback mechanisms. So let's look over here at some of these things. Okay, so this is just the same information that we just talked about on the PowerPoint, but let's look at it in a slightly different way. So parathyroid hormone. What conditions cause the hormone to be released? Low calcium in the blood. Which organ senses these conditions? Parathyroid gland. What does the hormone cause to happen to bone cells? It stimulates osteoclasts. And so since it does that to the cells, what does it cause to happen to the bone tissue? Well, the bone tissue, the bone matrix, is broken down, and so bones are less dense, not as strong. Okay. Okay, how does it affect the kidneys? Okay, so this is going to mean less calcium lost in the urine. And then also kidneys release calcitriol. How does it infect the intestines? Well, through calcitriol, we increase, so more calcium absorbed from food and drink. And so in the end, how does this hormone, parathyroid hormone, affect the amount of calcium in the blood? So in the end, blood calcium is increased. So we started off with low levels, and now we've increased those levels. Okay, so what I'd like for you to do to see if you can use similar logic here is to take this hormone calcitonin that we just talked about and see if you can enter the same information based on what we talked about. A couple of other things that I'm just going to share that might help you with some thinking activities. Okay, so thyroxine. Okay, this is released at different points in development and also based on your genetics. Okay, this is a hormone that's also released by the thyroid gland. And what it does is it stimulates osteoblasts. So, and then it has no effects as far as calcium levels on the kidneys or the intestines. So I want you to see, based on this information, can you fill in these last two boxes? Same for sex hormones, age, and genetics. Determine when sex hormones are released. They're released by the testes and the ovaries. They're also going to stimulate osteoblasts. As far as calcium is concerned, there's no effect on kidneys and intestines. And so again, I want you to see, can you fill in these last two? Okay. All right, and that is calcium homeostasis and how it's related to bones.